All right, so let's do the shadow problem that was from your related rates worksheet. And this one, the picture can get a little complicated, but it's really not too bad. And then it's actually asking us two questions. So the first thing it's asking us to find is the rate that the length of the shadow is changing. And then the second question asks the rate that the tip of the shadow is changing. So we actually have two questions. But first thing I'm going to do is draw my picture. So, it says that I have this street light that's 6 feet above the ground, or 16 feet. So here's my street light at 16. And it says that I've got this guy that's 6 feet tall. I could write today. Okay, so a man is 6 feet tall, that's right there. And a street light that's 16. Now it says that he's walking towards it at a rate of 5 feet per second. So here's the ground. Okay, and remember, in math problems, we're in a perfect world, so we've got right angles. And I don't know how long this is yet, but I know that this distance, since he's getting closer, it's going to be negative. So dx dt is -5, because it says that he's moving towards it at 5 feet per second. Okay? And then the first part is, at what rate is the length of this guy's shadow changing when he's 10 feet away from the base of the light? So if he's 10 feet away, that means that my x is 10. Now, if we think about this as a light shining up here, that looks like a flower, okay? But if it's shining from this, here's the top of the dude's head. This part down here is going to be the shadow, because the guy's blocking out the light. So we'll call this S for shadow. And right here is going to be the tip of the shadow. So that's what we're going to be looking at for the second part of the question. All right, but for this bit, it's asking us the rate that the length of the shadow is changing. That's going to be ds dt. Okay, so we got a lot of info. Oh, here's my perfect right angle. Okay, now hopefully what we see is that I have this big right triangle here. Okay, but I also have this baby right triangle here. Okay, and not only are they both right triangles, but they both share this angle right here. So by the angle postulate, we have two similar triangles right now. All right, and for similar triangles, we can always set up a proportion. Okay, so let's do that. I've got the height of my big triangle, and that's 16. And I have the height of my baby triangle, that's 6. Now, I know absolutely nothing about the hypotenuse of the big triangle or the small triangle. But I do know that the base of, I'll do the baby triangle first. The base of the baby is S. That's my shadow. Okay, now the base of my big triangle is going to be this X plus S. Okay, and now since we have this proportion, we can go ahead and cross multiply. And that's going to give me 16S is equal to 6x plus 6s. Okay, we should be kind of happy right now because now I have an equation that involves s's. So that's good because then when I take the derivative, I'm going to be getting ds dt somewhere. So I'm going to move this 6s, over, and I'm going to get that 10s is equal to 6x, or s is equal to 6x over 10, and I'm pretty sure that simplifies. Yep, 2 goes in there 3 times, and, sorry, did I do that right? 16, blah, 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 yep. So that's going to give me 3/5 x. Okay, now hold up right here. I'll write this as a new line. Okay? Don't feel tempted to plug in this x equals 10. Because if you do, you're going to get that s is equal to 6. And then when you take the derivative, you're going to get the derivative of constant, which is 0. Okay, so we don't want to plug in. We just want to get a nice function or a nice equation that has an s in it so we can take the derivative of. Okay, so we're not going to plug in stuff right now. And really, if you did plug in this 10, that means that when x is 10, then that's telling me what s is. And I don't want s, I want ds dt. So now I can go ahead and I can take the derivative. Okay, and we should see that this derivative is going to be good because here I'm going to get ds dt, which is what I want. Here I'm going to get 3/5 dx dt. Alright, but that's okay because the problem told me what dx dt was. That was -5. So ds dt is going to be 3/5 times -5, which just equals -3. And I think this was feet per second. So -3 feet per second. So that's the rate that the length of my shadow is changing, which if you think about it, it makes sense because as you walk away from the light, your shadow is going to shrink. Okay, so that was the first part. The second part is asking the rate that the tip of the shadow is moving. Okay, so, and again, this is kind of like what I just said. Your shadow is kind of dependent on both x and s in this case. Okay, because it depends on how fast your shadow is changing, but that is also dependent on how fast you're moving away or closer to this light. Okay, so the tip of the shadow, I'm going to erase this bit right here. Okay, the tip of your shadow, this was x and this was s, is actually, it's dependent on both of these. So I care about x and s. So I'm looking at the derivative of that whole side. But that's really nice because, let's see. Let's take a step back. So really that means I want the rate of change of this whole thing, which is x plus s. But we know that the derivative of the sum is the same thing as the sum of the derivatives. So this is really the same thing as dx dt plus ds dt. And coolio, they told me that dx dt was 5, and I just found out that ds dt was -3. So the answer is -8. I guess I probably should have labeled, how about we call this whole big side z? So that means that dz dt was equal to this. So here's dz dt. So there we go. So I just gave it a variable just so it's whatever. So the tip of the shadow is moving at a rate of -8 feet per second. And that's it. Boom, baby. Sorry for that if it did a weird pause. I actually paused this because I saw that there's actually another way to do this. And I mean, this is totally cool. Like, we got the right answer. But I want to go ahead and kind of expand on this z thing right here. What we did was totally fine. All right, we found s, and then we used that to add everything up and find z. But we actually could have done it in the opposite order. So what I'm going to do is, hold on. Let's see if I can get this to work. Ready? Copy. Paste. Boom, baby. Okay? So I'm just going to do this the other way, just so we all see. this was 16. Here was my x, and that was 10. dx dt, it's a horrible x, it's negative 5. My dude was 6 feet. Here was my s. And then here was my beam of light coming down. And here was the tip of my shadow. Okay, so another way that you could have done this, and it's very similar to what we did, is when we set up our proportion, we're still going to do 16 over 6, because we still have these similar triangles. But then, instead of writing this base as x plus s, why don't we just call this z right now? Okay, so then the length of my base is z for my big triangle, and then my little base is going to be this whole z minus this x bit, and then what I'm left over with is the base of my baby triangle. So this could be z minus x. Cross multiply, and you get 16z minus 16x. Minus 16x is equal to 6z. Okay, and I want to solve this for z because I already know everything I need to know about x. So subtract the 6z over, add the 16x, you get 10z is equal to 16x, or z is equal to 16x over 10, which really is 8x over 5. Okay, now, since we want to find the rate of change, we take the derivative with respect to time. We extend, and you get dz dt is equal to 8/5 times dx dt. But I know that dx dt is negative 5, so you get negative 8. So really, by breaking this into z and getting negative 8, notice that's what I got for my second answer. Okay, negative 8 was the tip of the shadow because the tip of the shadow was this whole length. So if we did it this way, we kind of answered the second part first because I found how fast z was changing, and z was this whole thing which goes to the tip. Okay, but then if I know that this whole thing, let me write that out, dz dt is equal to negative 8. Well, if this whole thing is changing at negative 8, and this little piece right here is changing at negative 5, negative 8 minus negative 5 is negative 3. So then I could use subtraction to find my ds dt. Okay, so there's more than one way to do this. You could find the rate for the shadow and then find the rate for the tip, or you can find the rate for the tip and then subtract to find the rate of the shadow. So either way, but that is how you do this. We are going to do more examples like this, but done. So, how's my time? Oh, beautiful. Have a great evening. Peace out, Cub Scouts.